So in this question, again, there is the application of VSEPR theory. So there are two compounds which are shown here, SeF4 and BrF4 minus. Okay, so these two compounds, we are given 4 statements about their shapes and geometries. So first statement says that according to VSEPR theory, the shapes and geometries of SeF4 and BrF4 minus respectively are seesaw and trigonal bipyramidal, the first option, seesaw and trigonal bipyramidal. Then the second option says square planar and octahedral, square planar and pentagonal pyramidal. Third option says seesaw and trigonal bipyramidal, square planar and octahedral. The fourth option says square planar and square bipyramidal, square planar and octahedral. So basically we are being asked the geometry and the shapes. So we have to understand the difference between these two. The shapes are the molecular shapes, okay, and the geometries are the parent geometries, which are regular geometries which arise from the arrangement of electrons resulting into a particular hybridization which gives the regular geometries. So that will be the electronic geometry of the compounds, while shapes depend on the number of lone pairs, how they are arranged, and that gives us the actual molecular shape of that particular compound. Okay, let's start with SeF4. Now selenium belongs to oxygen family. So obviously, even if we do not know the proper electronic configuration, we can understand that this belongs to group 6. That is why the valence electron for selenium should be 6, okay, and selenium here is the central atom. Okay, so selenium belonging to oxygen family has ns2 np4 valence electronic configuration, and number of valence electrons on selenium is 6. Then what about the number of electrons which are gained from the bonded atoms? So we have 4 fluorine atoms which are bonded to selenium. Then we calculate the total number of electrons, and that is 6 plus 4. So 6 plus 4 is equal to 10 electrons. And if we say that how many electron pairs, then we have to divide it by 2 and there will be 5 electron pairs. And the electron pairs, if they are 5, then it belongs to which hybridization? It corresponds to sp3 dehybridization. sp3 dehybridization, which has a regular geometry of trigonal bipyramidal. And we know how trigonal bipyramidal geometry looks like from the VSEPR theory. So if we put selenium like this, and then we have this kind of equatorial and axial bonds, something like this, 5, okay, so something like this we get, which is the regular TBP geometry. Now what happens in this case? How many bond pairs we have in this case? So there are 4 fluorine atoms which are bonded to selenium, so number of bond pairs is 4. So now how many lone pairs we have? Now we have total number of electron pairs as 5 that we saw. So 5 minus 4 is equal to 1. So we have 1 lone pair in this compound. And when there are lone pairs in the regular geometry, then the regular geometry gets distorted. So in this case also the regular geometry is TBP geometry. TBP is the regular geometry, but due to the single lone pair, this geometry gets actually distorted. So if we say the geometry gets distorted, then what should be the arrangement of the atoms? So we have 4 fluorine, so we place it like this in the TBP geometry, following the TBP geometry, and the lone pair is placed equatorially, something like this. Okay, so we place the lone pairs equatorially, and not axially. So here again a question arises, why not axially? That's because if we place it axially, then it will be very near to the bond pairs, okay, bond pair of electrons, and there will be too much of repulsion. So we know in VSEPR theory that there is a repulsion between lone pairs and bond pairs, and to minimize that we need to put these lone pairs away from the bond pairs. That is why the lone pairs will be accommodated in an equatorial manner in this compound. So ultimately, what should be the geometry? So if we see something like this, so we have, this is selenium, and then we have something like this. Okay, the fluorine atoms arranged like this. So the molecular geometry, so the electronic geometry gets distorted and the molecular shape comes out to be seesaw. So if we see it like this, so horizontally, then we understand that it is a seesaw shape. Okay, so from vertical to horizontal I am making, and then we can easily understand that it is a seesaw shape. So from TBP it gets distorted to a seesaw shape because of the presence of the lone pair, which is arranged equatorially. So the first part of the question is answered. So selenium has shape. So which shape? Seesaw shape. So seesaw. So first option and third option both have seesaw, seesaw. And then the regular geometry for SeF4 is trigonal bipyramidal. So first and third both options have trigonal bipyramidal. So these two could be our possibilities. And then to clarify the possibilities, we move on to the next compound, BrF4 minus. Now in BrF4 minus, we have obviously the central atom as bromine, and same for all halogens. The valence electrons for bromine are 7 valence electrons, okay? And then how many electrons are gained from the connected atoms? We have 4 fluorine atoms. So number of electrons gained are 4 from fluorine. And there is a negative charge also. So another electron from the negative charge. So total number of electron pairs comes out to be 7 plus 4 plus 1 from the negative charge divided by 2 to get the pairs. So 12 by 2 is equal to 6. And this 6 number of electron pairs correspond to sp3d2 hybridization, which has a regular octahedron geometry. So we have the electronic geometry, which is the regular parent geometry for this compound, is octahedral, coming from the sp3d2 hybridization, which is obtained from the total number of electron pairs. Now, how many bond pairs we have? So we have 4 bond pairs from the 4 connected fluorine atoms which are bonded to bromine here. So number of bond pairs is 4. Now how many lone pairs? So total electron pairs are 6, bond pairs are 4. So 6 minus 4 is 2 lone pairs. So we have 2 lone pairs. So in the octahedral regular geometry, if we have 2 lone pairs, then the geometry is distorted to square planar geometry. Okay. So this also we have seen while learning the VSEPR theory, that how the geometry is affected by the presence of lone pairs. So the octahedral, which is the regular geometry, when there are 2 lone pairs, it is distorted to the square planar geometry. So let's try to draw what should be the shape of this molecule actually. So we have drawn a square planar shape. So Br in the center, bromine in the center, and at the 4 corners of the square and a planar structure, we have the fluorine atoms connected to bromine. So this is the square planar molecular shape of this compound. Now coming back to the question. So we selected 1 and 3 which satisfied the first part of the answer for SeF4. Now let us see the second part that we deduced just now. So in option 1 it says seesaw and trigonal bipyramidal, which is not correct for BrF4 that we just saw. And then the third part says square planar and octahedral. Yes, that satisfies our answer and explanation that we saw for BrF4 minus just now. So the correct option for this question is option 3. So SeF4 has a seesaw shape and a trigonal bipyramidal geometry, while BrF4 minus has square planar and an octahedral geometry. So I hope this explanation is clear, and this is again a question which is asked in one of the competitive examinations, and it will be helpful to all the students preparing for any kind of competitive examinations for chemical sciences, and I hope it is helpful, and thank you so much.